Here I have a problem from the University of South Carolina math contest from the year 2015. And it tells us that if the larger base of an isosceles trapezoid is equal to the diagonal of that trapezoid, and the smaller base is equal to the height of the trapezoid, then what is the ratio of the larger base over the smaller base? So let's get into the solution. First, we want to draw out our trapezoid, like so. And remember, this is an isosceles trapezoid. You could draw it upside down, but I'm just going to draw it like this. And then I'm going to segment it so that the larger base is split up in terms of the smaller base and these outside bits. So I'll call this smaller base length A, which means that this length here between this orange point and this orange point is also of length A. But because the way the problem is stated, we know that the smaller base is equal to the height. So that means that each of these heights here are of length A as well. Next, I'm going to assign values to the lengths between the dots and the corners of the larger base. We'll call those length Y. And finally, we'll call this big long diagonal of the isosceles trapezoid that I'll color in yellow, we'll call this X. But now we know that the length of this bottom base, this larger base, is equal to the diagonal. So let's write down that equation. We know that 2y, that's from these two green lengths, plus a is equal to x. And let's see what else we know about this trapezoid. We know that these angles here are both right angles. So we know by the Pythagorean theorem that y plus a squared is equal to x squared, because x is our hypotenuse here. But now we can substitute in 2y plus a for x in this equation. So doing that, we get y plus a all squared plus a squared equals 2y plus a all squared. Now let's expand both sides of this. So we'll have y squared plus 2ay plus 2a squared. That's by combining the a squared from this expansion with this a squared here. And then we'll get 4y squared plus 4ya plus a squared over here. So now let's collect all of our terms on this right-hand side and leave a 0 here on the left-hand side. So we'll have 3y squared, that's from this 4y squared minus this y squared over here, plus 2ay, that's from this 4ay minus this 2ay, minus a squared, that's from this a squared here minus 2a squared here, and that's all equal to 0. Okay, so I've brought this equation up to the top of this board, and I left our two equations from before up in the top right. But it turns out we don't actually need to use the quadratic formula for this. We can factor it out. So we'll have 3y here on as the first term and y as our second term. And then we need to have two components that multiply to a squared that add to positive 2. So that means we'll have plus a here, that gives us 3ay here, and then minus a here, that gives us negative ay, but that adds up to 2 and multiplies to negative a squared, like so. But that means we have y is equal to a over 3. And notice we don't really care about the solution y is equal to negative a, because we're working with side lengths here, and a negative solution doesn't really make a whole lot of sense. So this is the solution that we'll take as ours. Y is equal to a over 3. And then we'll plug this back in to our top orange equation over here. So we'll have 2a over 3 plus a is equal to x. But that means that x is equal to 5/3 a. But notice that's exactly what we're looking for, because we know that x is the length of the larger base length in this isosceles trapezoid, and a is equal to the shorter length, and we have our ratio of our larger over our smaller, that being 5/3. And that's enough for now.